3, 2, 1. This reaction right here is known as a cyclopropanation of an alkene. So we take an alkene, a species known as a carbene, and we form a cyclopropane ring. Now you already know your alkenes, but what is a carbene? A carbene is a carbon species that has 2 unpaired electrons. However, it's neutrally charged. So while there's no charge pushing it around, it does not have a filled octet. So it is very reactive and it's looking for those electrons. So what it does is it adds to this electron-rich pi bond, which then attacks back, and we form our cyclopropane. So how do we get a carbene? Well, you can take diazomethane, where we look like this, CH2, and then plus, no, I'm sorry, there's one here that looks like this. However, there's a resonance form where we are triple bonded right here, and then these electrons come here. If you expose it to ultraviolet light and some heat, you're going to form your carbene and then N2 gas. Now you have your carbene. However, a really popular way is what's known as the Simmons-Smith reaction. And it was discovered by 2 guys at Dow. I guess their last names were Simmons and Smith, and the reaction's named after them. And what is, you take methylene iodide and you take zinc copper couple, which is essentially zinc dust, just with some copper kind of as a, I can't think of the word, as an impurity. And you get what's known as a Simmons-Smith reagent, which isn't a carbene, it's called a carbenoid, where it's written kind of like this. And you can think of it like, ooh, that shouldn't be a big N. Oh my God, why do I keep making a big N? Now this is a carbenoid because it functions as a carbene, but it isn't a carbene itself. We still can react it with an alkene to get our cyclopropane. Simply pack that. And, ooh, no, I'm sorry, we're coming right to our CH2. Bad arrow on my part. And then this comes here. And then we form our, ooh, oh my God, I'm all over the place today. We form our cyclopropane. Now, there's another way we can do that, and that's with trihalomethanes. So if you have a trihalomethane, I'm going to use CHBr3. If you react that with potassium hydroxide, you're going to get potassium. You're going to get what looks to be a carbene, or the beginnings of a carbene. You're going to have B3 minus, and you're going to have H2O. Now, this beginnings of a carbene that I was talking about, the carbon doesn't carry that negative charge, as well as some of the other things that we have here. Now, what we can do is we can kick these electrons off. This forms our carbene. Now we can go and react this in a cyclopropanation reaction where we have our alkene. We add back, and we have formed our cyclopropane. Those are 3 common ways to do that. Now, when we form our cyclopropanes, we have to remember the stereochemistry. That's a concerted reaction. So the stereochemistry is locked in place. So take 2 different molecules here. One is cis, one is trans, 2 butene. So if we cyclopropionate the same one, because this is the stereochemistry is locked in place from whatever our alkene is, we're going to have our cyclopropane here. Oh my God, I can't draw today, guys. And our cyclopropane. Now, because this one was cis, this one's going to stay cis. We're going to have our protons on our wedge bonds here. Not the best wedge bond, but it's a wedge nonetheless. Now this one, it was trans, so it's going to stay trans. And then we have our protons over here. So whatever the stereochemistry of your alkene was, that's going to be the same stereochemistry of your cyclopropane. And for more organic chemistry learning, please hit that follow button. Check out all the videos we have. Let's get you that A.